Lovely students. Welcome to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming to you to today's session, which will be covering the most important questions from Lesson 11.1 Trigonometric Identities. This is a must-watch video, and upon the request of my students and subscribers, this time I have brought for you a long video. Make sure you watch it till the end to get maximum benefit, and also like, share and subscribe to the channel. Spread this video as much as you can to all the students of grade 11 advanced so that all of them can benefit from this session and understand lesson 11.1 trigonometric identities and how to apply it to solve questions nicely. So on that note, let's start with today's video. Some more important questions on simplifying an expression from lesson 11.1 trigonometric identities. I hope by now you have learned all the identities and you have watched my video on the summary and the formula sheet for lesson 11.1. So let's use that for simplifying the first question. So here in question 2a, you need to simplify each expression. Now you see this is a fraction, it has a numerator, it has a denominator. There are so many terms, tan square theta, cosecant square theta, secant square theta and 1. So we want to reduce the number of terms if we want to simplify and maybe just make it 1 or 2 trigonometric ratio. So let's do it. So I'm using the basic definition. I'm using first question identity. So I will try to convert everything in sine and cos. So I replace tan with sine over cos. Also I will use here reciprocal identity for cos secant. So cosecant theta is 1 over sine theta. So quotient and reciprocal. What else can I use? I can also use reciprocal identity in denominator to simplify, because I know secant theta is the reciprocal of cos theta. So these three identities, when you plug in it here, what do you get? Let's see. So in place of tan square, I get sine over cos theta, and there is whole square, don't forget. And I'm multiplying this with 1 over sine theta whole square, minus 1 as it is, and the denominator I have 1 over cos theta whole square. Now before I proceed, I would like to simplify this, and if you see sine theta whole square is in numerator here and sine theta whole square is in denominator, so it will cancel. Let me make it easy. So I'm just left with 1 over cos square theta minus 1 over, in the denominator, 1 over square theta. Now I will take LCM because I want to make denominator equal. So I multiply up and down with cos square, and in the next step things are going to reduce for me. So final thing I get is 1 minus cos square theta over cos square theta divided by 1 over cos square theta. Now I'm quite sure you'll be able to identify that this whole thing cancels. So we are just left with 1 plus cos square. And again, I can use the identity of Pythagorean, which tells you sine square theta is 1 minus cos square theta. So your final answer for this question would be sine square theta. That is how we simplify. That is how we reduce the term. So that's your final answer for 2A. Similarly, I would want you to try question 2B. Take 2-3 minutes, and then if you're stuck, watch my next slide and you will get the answer and steps for 2B. It's a time to check your answers and to see how much you've understood about the identity. So we need to simplify this one definitely. Very clearly, I can see here one step is to apply the Pythagorean. 1 minus cos square is given. So you know sine square theta plus cos square theta equal to 1 is the Pythagorean, and if I want the value of sine square theta, I move cos square to the other side, so 1 minus cos square. So directly here in this step I can replace 1 minus cos square with sine square theta. Okay, now what about secant? Yes, I can apply reciprocal. So secant theta is the reciprocal of cos theta. So plug it in there and replace secant with its reciprocal. Now sine square theta divided by sine theta, we can cancel one sine theta. So you are left only with one sine theta here. So sine theta in the numerator is left, and in the denominator cos theta. So now can we use the question? So sine divided by cos is tan theta. So the final answer for question 2b is tan theta. That's how you simplify, that's how you reduce your trigonometric terms. Let me know in the comment section how many of you got the correct answer for this question. Hello and welcome, my dear students. So let's solve this question on guided practice 3, where you simplify and use expression. So read the question carefully. Cot square theta minus tan square theta in terms of sine theta. So let's use the basic definition of questioned identity. This question I'm going to solve using questioned identity. So what is questioned identity? Questioned identity for tan theta is that you get tan theta by dividing sine theta with cos theta. I also use questioned identity for cot, which is the reciprocal of tan. So cos theta divided by sine theta. So I'm going to plug in everything here in this expression. So let's do it. So I get this one as cos theta over sine theta whole square minus sine theta over cos theta whole square. So let's open it up. So this is cos square theta over sine square theta minus sine square theta over cos square theta. Now we want to make denominators equal. So I write sine square theta times cos square theta cos 4 theta minus sine 4 theta, taking LCM. Now I can use a little bit of algebra. So the identity I will be using is difference of squares, where a square minus b square will be a plus b, a minus b. So I will be writing this cos 4 theta as cos square theta whole square, and I'll be writing this sine 4 theta also as sine square theta whole square. Why I do that? So that the power is 2 and I can apply this identity. So what I get here is cos square theta plus sine square theta, that's a plus b, and cos square theta minus sine square theta, that's a minus b, over sine square theta times cos. Now think about it. How can we simplify more? Yes, we can take the help of Pythagorean. So Pythagorean tells you sine square plus cos square theta is 1. So this is gone, khalas. We're only left with cos square theta minus sine square theta. Now we want everything in terms of sine theta. So can we replace using Pythagorean again? That means wherever there is cos square, I can remove it and make it sine square by using Pythagorean. So last step would be in this formula, wherever you have cos square here and here, plug in this value. So when you do that, the final answer will come out to be this expression. So this is your final answer, 1 minus 2 sine square theta over sine square theta minus sine 4 theta. So now I'm providing some very important questions which can really help you for practicing this topic really well. So I would urge you, I would request you to try and solve these questions yourself. I will quickly do some of them here, remaining you can try yourself, very easy, and this will teach you how to apply all the identities that you've learned in this lesson. So let's do maybe 22 here. So cos pi by 2 minus theta. Very easy to identify. This is co-function identity, and cos of pi by 2 minus theta, I will write here. This is the identity I'm using. So co-function is equal to sine theta. Opposite is also true. So sine pi by 2 minus theta is equal to cos theta. So these are your co-function identity. If we use it here, this thing becomes sine theta, and you know cot theta is the questioned identity. I will write it on this side. So cot theta is cos theta divided by sine theta. So plug it in here. So cos theta over sine theta, and it's very easy to identify that sine and sine cancels. So the final answer simplified is cos theta for 22. Now again you see co-function in question 25. I can use this identity sine pi by 2 minus theta is equal to cos theta here for question 25. So I replace this thing with cos theta, and then I can use reciprocal, that secant is the reciprocal of cos, and then when we simplify and cancel, we are only left with 1. So the final answer for this question 25 is 1. This is how you simplify. Again, one last question I'll do on this slide, remaining a very easy. Here you can use Pythagorean. Here it is negative angle identity. You know cos is an even function, so cos of a negative value is positive, so plus cos theta. And sine of a negative value. These are the negative angle identity. Being an odd function is negative, so negative sine theta. Now again, you can use quotient identity. Cos divided by sine is cot, so minus cot theta. That's going to be your final answer for question 26. Now I would want you to check your answers, and these are the correct answers. Now we move on to one very important part of this lesson, which is the word problem. So I hope you have watched the video completely till here so that you are confident in solving these kind of questions. So now I will do 27 for you, 34 you can try similarly. So first we are going to read the word problem together and highlight the important information, and then we'll see what the question is asking. So when there is current in a wire in a magnetic field, such as hair dryer, a force acts on the wire. The strength of the magnetic field can be determined by the formula. So one thing which is very important is the formula. It's a trigonometric formula because you see the ratio cosecant theta. It is the reciprocal of sine theta. You should always remember. So I think reciprocal identity is going to help for us. And yes, we are right, because finally rewrite the equation in terms of sine theta. So to reach to sine theta, we have to take the help of reciprocal identity for question 27. So let's do that. F is what? F is the force on the wire. So just highlight the important information. I definitely is the current. L is the length of the wire. Theta concerned is the angle. And now we try to solve this question. So let me do all the steps in the next slide. First thing I will do here is substitute the value of cosecant theta in terms of sine, because that is how I want my final answer. And then we need to write the equation in terms of theta. So B will be F over I is the current, L is the length. So F we already saw is the force, I is the current, L is the length. This is unchanged. We don't do anything. We only change cosecant. So I put in place of cosecant 1 over sine theta. Now let's go back to the question. I will read this part again. F is the force, I is the current, L is the length, theta is the angle, and we just need to rewrite the equation in terms of sine theta. So have we done that? Yes, so this is B. B is denoting your strength of the magnetic wire. Yes. So strength of the magnetic field. Okay, now sometimes in ministry they will ask you to rearrange this. That means what? For example, they will ask you to find the value of force, capital F. Then what will you do? You will do cross product. See, there are fractions involved. So B multiplied with IL. This gets multiplied and the sine theta will be equal to F. Okay. So this can also be one of the answers. So this is just an extra thing that I'm giving you in this video. So if they want you to solve for F, this is your answer. Okay, that was the hint given. So now try the next question of the word problem yourself. Answer has already been provided. So that brings us to the end of today's long but very useful session. I hope you liked today's session and it helped you to understand lesson 11.1, how we apply the trigonometric identities to solve question. If this video was useful, give it a thumbs up, like, share and subscribe to the channel. And don't forget to press the bell icon so that you don't miss the notification for my upcoming videos. Let me know in the comment section which video you want me to make next, or which topic you want me to cover and simplify for you in your journey of learning trigonometry. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye students.